Electron beam welding of aluminium. The electron beam welding is associated with energy densities of more 1000 W cm2. A vaporization of the metal occurs above 100 doses. The electrons emitted from an incandescent electrode and accelerated in an electron gun are focused to bombard the work placed in a vacuum chamber. An arrangement of deflecting systems is used to make the beam move. The work can also be moved along different axes so that the welding location is accessible. Welding can be carried out with or without a filler metal. The formation of a vapor cavity or deep weld effect is typical for beam welding processes. A cavity consisting of a vapor core surrounded by molten metal is created. The beam can thus penetrate through the whole thickness of the metal. Vapor pressure and surface tension have a twofold effect. They keep the cavity open towards the top and thus allow an unhindered beam penetration and at the same time allow the weld pool to flow together or allow a crystallization in the beam vicinity. The surfaces to bead joint are mechanically worked or, as in the case of extrusions, have a specially formed lips which help to position the parts to be welded and serve as weld pool supports. Weld pool supports in the form of grooved sections are usually not used since the high-energy beam reaches right through to the bottom of the joint. This would lead to an undesired welding. The remaining weld pool supports tend to reduce the dynamical strength. For this purpose, joint forms and machining allowances are designed. Joints made by the electron beam welding process are characteristically extremely narrow and deep. The ratio of weld thickness, throat of seam, to weld width lies between 5.1 to 25 pm. Thus, it is possible to weld even thick sheets with a square butt joint with the electron beam welding process, where the other welding processes would require large V angles and filler metal. The figure shows terms used for describing a weld. Generally, aluminium and its alloys can be welded easily with the electron beam welding process. Among the non-heat treatable alloys, the hot cracking tendency increases with increasing magnesium content. The cracking tendency depends on the contents of magnesium and silicon. The heat treatable alloys have only a limited suitability. Due to the reduced heat input, the alloys containing copper can be easily welded. It is known that the weldability of copper-containing alloys with other welding processes is poor. Aluminium alloys up to 40 mm in thickness can be welded. Even here, experience shows that AlMg3 alloys can be welded only by adhering to special measures. The beam, with its high energy density, causes a relatively high amount of magnesium to vaporize so that the remaining content now lies in the range of 1005%. It is just this magnesium content which causes a maximum amount of cracking. Thanks for watching. Remember to like, comment, and subscribe.